next talk will be given by Ale Raza from ISPRS. Rafi is here and has already uploaded his slides. Raza is a senior software engineer with ISPRS, and I think he will talk about the spatial temporal data model in ISPRS. All right, over to you, Ale.
Thank you, Mr. Chairman. My name is Ale Raza, as introduced me, and I work with ISPRS. I'm going to share with you some of the experience that I have working on this spatial temporal data type. It's a sort of a research project and it's early results. So I will introduce you that what are the issues with this spatial temporal data type, and what is a spatial temporal data type. Some constructors, SSL functions and operators used for this data type, and some implementation details and examples, and conclude my talk with some of the remarks or future work. So discussion on spatial temporal data type is not new. We have seen in the last 2 decades that a lot of work has been done, starting from simple to complex data modeling and query language and spatial temporal indexes. So we have seen that Lagrange work and space-time composite, and then Warburg work, space-time cube and cell topologies, spatial temporal data models. Similarly, temporal query languages, where people research in this area, that how we can use this. And folks work on spatial temporal indexes also, where they extended the traditional R3 indexes to the to include the time dimension along with the space. And so apart from all these developments, we do not have temporal GIS. Still there is no commercial temporal GIS. What is the problem? Well, we can attribute to 2 issues. One is that it is complex issue. Second is there is a lack of standards for spatial temporal data modeling or data type. Well, most of us, we know that there is a spatial type exists, and there is an ISO standard for this, there is a SQL-MM standard for this, there is a OpenGIS standard for a spatial type. But there is no standard for the spatial temporal data type. And why we need this standard? To ensure that this is implemented uniformly across all platforms and software input outputs are known. Another aspect is that the GIS is not a separate black box code sort of thing. It is becoming an integral part of enterprise databases. So the database administrator want to know this type input, output and its behavior, that how it's behaving before they can integrate this type into their system. And it is, the GIS is no longer considered as a separate branch from the mainstream information technology. It's becoming a part of information technology. So there's a need to have the standards for this spatial temporal data type. So if we look at the implementation of the spatial type, we know that last 10 years we have seen that Oracle Spatial is there from Oracle. DB2 have the spatial type, Informix, which is also from the IBM right now. ST Geometry for Postgres open source database from, and Oracle from ISPRS. SQL Server geometry type and geography type from Microsoft. So these are the commercial software, but apart from this, I mean, the open source community also very active, and one of the important type we have is PostGIS from Postgres SQL, is from Reflection Research. So this is the open source spatial type available. So how we can start this? Basically, you have a space and time, so you have to integrate this in a way that the time is not an attribute of the space, but it is an integral part of the space. When you integrate this time and space, then you get a spatial temporal type. Because all this type is based on the object model, so everything is a object. So you get a spatial temporal class. Again, it has three subclasses: st point, st line, and st polygon. St point means spatial temporal point. It means that each object have a start point and end point. So each spatial object have this start and end point. Similarly, there is a concept of st collection, which is abstract class, and it has three subclasses: st multi-point, st multi-line, and multi-polygon. This is some of the attributes and the operations of this type. So you can see that there are some data members like SRID, which represent the special reference ID of this object. It represents the spatial temporal entity type, what type of the object it is. It is a point or it is a line or polygon. It says that what is the start time, what is the end time. And the geometry is stored in a binary format in a C-shape rather than just a binary representation of the actual geometry. There are some functions associated with this type. I will talk in a later slides. For example, STT SRID is just return you the SRID associated with this object, or you want to find out that ST time overlap, either these two intervals overlap or not. So these are some of the examples of this operators on this class. This is a schema of the if you want to implement spatial temporal data type, or you can say very simplified information model where you have a metadata for this spatial temporal type. Let's say that this is a feature class representing the some rivers. So you will represent this in a type column, may have some properties, but this spatial temporal column have certain metadata. For example, it has a SRID, it says that what is a column, what is a table name, what is the owner, what is the schema in a database where you are storing this information. And here you have the information about the SRID, that what are the attributes of the SRID. And this SRID is coming from the coordinate system, which is a well-defined coordinate system. So as I mentioned you earlier that the type consists of the three parts: constructors, accessors, and operators. So there are two types of constructors provided for this type. So one is the text-based constructor and one is a binary constructor. For example, STT type is a text-based constructor where you specify the WKT with time. So this WKT is a well-known text. This is a very known, known standard text for representing the geometry. It is documented in ISO and SQL specification. So WKT with time is just an extension of WKT with the time information, where time can be interval or a point time. The second operator, second constructor is a binary constructor, where you can specify the WKB, which is a well-known binary format, or ESRI shaped format with SRID and time information. So as you can see that here the time is a separate argument, while in this one it is a part of the WKT string. Here are some of the examples of the accessor function. For example, if you want to return the geometry as a text, so you can say that STT as text, and it will return the spatial temporal type in a text format. Or you want to, if you want to return as a binary, you can say as binary, and it will return in a binary form. There are some other functions here. Third type is a operator. So we can define the operators into three parts, as we are dealing with a spatial temporal type. So it can be a very pure temporal operators. For example, either these two events or the intervals are before each other or not, or either they they overlap or not. Similarly, you can have a special operator. For example, these two objects contain true or false, or they intersect, true or false, or overlap. So these first two types of operators are very well understood. People have been working on it, so it's very documented also. So there's no need to explain more. But the important thing that I'm going to talk about is the spatiotemporal operator. For example, STT contains is a spatiotemporal type contains. This type contains the contents of the spatial part and temporal part. For this implementation, I focus on the ST type overlap, which is the overlap of the time and overlap of the spatial function and overlap of the time function. Though you can have a lot of combination. For example, you can say that ST contain N before, ST contain N after, ST contain N overlap, and so on. This is a list of the spatiotemporal operators. Some of them I just mentioned in a previous slide. So contains and before, ST overlap. So we can formalize these operators based on the set theory. Let's say that A and B are the two spatiotemporal objects. G is the geometry and T is the time. So if you want to formalize STT overlap, then if the intersection of boundary of A and boundary of B is not empty, and intersection of boundary of A and exterior of B is not empty, and intersection of exterior of A and boundary of B is not empty, and intersection of time A and B is not empty, then it is a spatiotemporal overlap operator, or the two objects overlap in a space and time. So this type is implemented in an open source database, which is a Postgres 9.1. Basically, it's an extension of the ESI ST geometry type, which is already implemented out there. And time is represented in the ISO format. So there is no time stamp there, it's only date time is supported at this time. This is a, just for the example purpose, this shows the San Diego parcels, about 800,000 parcels. Original data was not time series data, but just for the sake of demonstration purpose, I divided the parcel into different time periods. So for example, from 1970 to 72, there were 500 parcels, and similarly from 2001 to until now, like 83,000 parcels about this. So this just shows the distribution of parcels by date. Here, this is a very simple example. If you want to work with the spatiotemporal data type and you want to create a table with this, how you will create. So very simple example, create table, parcel, object ID, real type, which is auto increment type, and you define the shape column, and then you define the type. But it's like any other type in a database, like integer type or date type, or you just name it. And second part is that you start inserting your information if you are using a WKT constructor. So you say insert parcel value ST type, and then you define the polygon, which is standard in a WKT format. And the second part, which is more important here, is the time here. So you add the time after the WKT text, and you define the SRID with this information. So third part is the query part, or the operators that if I want to retrieve the information based on some constraint or some filters, how I can use these filters. So this can be very simple one. It can be like a time filter, very simple, no special constraint. It can be only spatial filter, no time there. In a time filter, there is no spatial filter. In a spatial filter, there is no time filter. While in the spatiotemporal filter, both filters are there. And special temporal filter can be a simple filter or the range filter. Simple filters are time instance, like a point information. For example, 1970, or if you want to represent the 1970 to 1970, the system will take it as a point rather than an interval. But if you have two different times, then this will be considered as an interval time. So here I'm talking about the simple instance is a point interval, while in the range filter is a time interval with the spatial filter. This is the example of showing the data using the filters I just mentioned you earlier. Very simple example is that show me all the parcels in 1970 that interact with a given window. So what is window in this case? It's a filter that I have talked about. So this is this part, that polygon with a time instance, and you provide the SID. So I want to say that select ST as text from parcel table where ST key intersect, and you specify the shape from the DBMS, and you provide the filter in this part. So it will intersect all the polygons, and it will intersect the time where this intersect is 2, it will return all the polygons. So in this case there is one polygon, and you see that it's returned in the WKT with time format. Similarly, if you want to say that find all parcels during 1990 and 91, then you can construct this very simple query that select all from parcel where STT time overlap, I think it should be STT, yeah, overlap shape, and then you specify the polygon and time information. So there is an example of another filter here. So depending on how you use the filter, you can retrieve different information. But you have to be careful that what you want to retrieve and what type of filter you are using. So this was very simple examples of how we implemented and how you can use at a SQL level these type and work with this spatial temporal data type. So I would say that new type, we introduced a new type, spatial temporal data type, and some operators and constructors and accessor functions are defined, but there is a long list of the other functions also we have to document. This comment currently binary data is written in a WKT format or PSI shape format without date information. It's not true. I mean, it was true at the time of writing a paper, but we return binary and a WKT information with time. Similarly, this comment about indexing that is need spatial temporal indexes. This is also implemented. I wrote it at that time when we was writing a paper. So this part is implemented and this part is implemented. So we have the spatial temporal indexes, space-time indexes. And we hope that the implementation of this type would help us to implement the temporal GIS today. And with this, I would like to thank you. And if you have any questions, you're welcome.
Thank you, Ale. Maybe I start with questions. You said that everybody knows, but sorry, my ignorance, I don't know. The difference between the intersect operator and the overlap operator. Is there a difference?
Overlap time operator, overlap spatial operator.
For both types you had the intersect as well as overlap.
Right, so in a overlap, time operator is a spatial operator where the order is ignored.
Right.
So it is an intersect operator. In fact, there is no intersect operator for the time operator. It's only before, after, right, and left. So there is no intersect operator there. But the overlap operator is the one that which do not have a ordering concept. So either is intersect with the left or right, is overlap operator.
Okay, thank you. Other questions? Yes, please.
Saying that in the new spatial
question is that she's asking that in a new type, if you just add the time, then time text, then it will, yes, sure.
And then the problem is that how to use the new type to do some spatial temporal analysis. We just add a special tag. You know that I think for the special temporal data analysis, the problem is that how to understand the process of the spatial temporal evaluation. Okay, and it just react. It's easy to add a time tag in the database, but for the simulation, the process of the spatial tag, and
Yeah, I mean that's the issue that you have to deal with this. I mean the concept of time is that how you define it, where you define it. Like I said, that using operator, you should be very careful that where you're using this operator, what you want to achieve there.
and is that the new type was shown in the new version of the AppList?
No, it's not implemented yet. I mean, it was a research project, so it's not yet there. So we do not know that either it will be in or when it will be in. I cannot say anything. But yeah, some time support will be there in the next release, but this one, we have no idea. It's still an ongoing research.
All right, more questions?
You mentioned that one of the challenge you are facing in technology races related to the standards and complexity of the files. But there are many challenges which to be solved before we go to a standard. For example, the topology, the temporal topology, and the constraints which we have to put for temporal data. Do you think that if we have a temporal standard, then we can go to the complete version of the data?
Yeah, I mean those issues are still there, but like I said, this is a starting point. So, but it is similar to the spatial type. Once you are working with a spatial type, topology is not defined there. Topology comes later. Either you define topology on the fly, or you explicitly store the topology. So there are two approaches there, how you deal with it. So the standard never talked about the topology. If you look at the ISO standard or SQL standard or OpenGIS standard, they never talk about topology. What they talk about is a simple feature implementation of the spatial type.